Okay. Hello. Okay. Are you ready?
I'm ready. All right. Hello, and I will stand in front of the camera.
Nope.
Just
get a little more.
We're trying to get you there.
There you go.
Hello. This is Lifting Stuff Up, and we are going to talk to you a little bit about lifts and various types that you can use on your robots to solve a whole bunch of different problems. We know it's hard. Hopefully we will make it a little bit easier for you. We are doing this at UVic, and we'd like to thank the Engineering and Computer Science Department for hosting us and giving us a space to run these workshops. So, these are the 5 types of lifts that we're going to be talking to you about today. So, the scissor lift, the gear rack, linear slide is one type of lift, but we're going to show you 2 different stringing methods that have advantages and disadvantages, and drawer slides. We have examples of all of these here today, which we'll try to show you at any opportunity that we get. And let's go on and talk about the first kind.
Alright, so to begin with, we're going to be talking about scissor lifts. This is a very common type of lift that you see in industry. They are reasonably easy to build and can be built pretty high up and become pretty compact when down. They can be very smooth and very fast. The one thing is that they do need 2 arms in order to be reasonably stable, and so the base can be wider than other lifts. We have a couple examples here. Pass around. As well as a larger one from a past robot as well, you can see. Generally, they use gravity to lower. However, I have seen teams that have powered it both up and down using a threaded rod. However, that usually generates in a very slow up and down.
Alright, okay. So the next type of lift that we're going to be talking about is gear rack. Now, gear rack is the only type on this list that is mechanically powered both up and down in most circumstances. It's very easy to control because, as mentioned, it's on a motor the entire time. So you can control the speed and you can stop it halfway if you'd like. It's great for shorter lifts because it's very stable, everything is controlled by a motor. But if you want a tall lift or anything larger than the length of channel you have, then, or the length of this kind of rod you have, then you'll need to put a motor between the 2 sections, which means you have a very high center of gravity and your robot very quickly becomes very unstable and your lift doesn't work very well. Now, the load is directly on the motor, and unlike all of these other kinds, it's a little bit harder to take the load off the motor using chain or gears. So just beware that you're not putting too big of a load on your motors because they will burn out, they will stop working, etc. It's very easy to diagnose problems and fix because it is so simple. Unlike the linear slides, you don't have string, you don't have a bunch of bolts that you need to check like the scissor lifts. So it is very, very simple because, as you can see, it is mostly just what looks like a gear and some gear rack. It goes up uniformly. However, it should be attached to a beam for a little bit of extra stability. And you need to watch for gear slippage, which is the only real major maintenance concern. And yes. So that's why we like gear rack. However, it does have its advantages and disadvantages, just like any other type of lift. We have some examples here. So this is an example of a gear rack going up and down. Yeah, there's no really good way to show this on the camera. So yeah, okay. So you can see in here we have the gear and we have some gear rack.
Actually, back a little bit. Yeah. Okay, try that.
Okay, so you can see in here we have a gear and we have some gear rack. This is to simulate where the motor would be, so as you turn this, it can go up, it can go down. And I think those are the only examples we have of that.
So next we're going to talk about 2 different ways of powering linear slides, or 2 different ways of straining them. The first one's called the continuous linear slide. In this configuration, you have one single string that is fed through all the pulleys. It is the easiest way to raise them. However, it does mean that every segment of the slide will raise one at a time. So the more segments you have, the longer it's going to take to raise up. Just like the scissor lift, it does rely on gravity to lower, and it is, as mentioned, slower than the cascading configuration, which I'm going to be talking about next. We do have an example here. So here's one where you see how the string is fed up and down. If you pull on it, each segment raises one at a time. This is an example using drawer slides. We also have another example over here, which is probably easier to show a bit later, using the rev pieces as well. With any slides using string, you always have the issue that it requires a bit more maintenance to feed it through and make sure they don't fall off the pulleys. So the second configuration is called cascading linear slides. This one's a bit more complicated. In this configuration, the segments are connected in shorter pieces of string that overlap. Using this method, it means that every segment is raised simultaneously. So no matter how many segments you have, it'll read the maximum height in the same amount of time. So it's considerably faster, and you can build as high as you want, assuming your motors are strong enough. So I mentioned it's a lot faster. It's a bit more meticulous setup, because you do have to make sure every piece of string is the same length and tied at the same length. It's a bit harder to visualize. I've tried to kind of show with different colors, so each color is a different separate piece of string, with only the last one actually being connected to a motor.
Wait, isn't that last one like shorter? Like the black one?
The black one, so the dot were the motors, so wherever the motor is, where it ends.
But it should be the same size as all the other strings.
That one can actually be as long as you want, because that's the one that's wound around the motor and is wound up. The other ones have to be the same length, so if you see here, this one will be around the motor, and they all go up at once.
Can it be as short as that one?
Hmm?
Can it be as short as that one or no? You say it can be as long as that one, can it be as short as that one?
As long as it is long enough that when it's down, it still reaches the motor, and then you just have to wind it up as far as it'll go.
Relating to all like string stuff though.
Sorry?
Relating to like all string like slides, isn't it also like more like less secure? Because if a dental robot like bumps you, it could either snap the string or like get off the pulley so that your linear slide is just dead.
I mean, that is I think the danger with any linear slide, is that the string can come off the pulleys. Because they are all separate, you do have the danger that if one slide is stuck somehow, and this one's stuck and this one starts going down, the string can pull up. However, again, that's kind of the case with any linear slide. If one section that slide itself doesn't want to move and the string is being released, it can come off because it's losing tension.
In that case, cascading linear slide is technically safer because if one breaks, the other one would possibly still work. Is that how that works?
No, because if one of these isn't fed properly, that's also the problem with if the string stretches or if they're not the same length. Because if the very first one isn't the correct length, the next one won't raise all the way. Alright, and again, with all the other slides, relies on gravity to lower, and it should have 2 in order to be stable. Oh, I have a quick question about one of the robots here. We're going to get that to, or I mentioned at the end. All right.
Okay. So our final type of slide is the drawer slide. Now these are really nice because they're pre-made assemblies, so you don't need to worry about grease and bearings and all that. So it reduces some of that work with making sure that your assembly slides correctly. It does require some sort of beam or channel to attach to, like all the other types of slides here, so be sure to account for that on your robot. You need to motor it, you need to motorize it, but it only requires 1 motor per slide, and you can even use multiple slides with 1 motor as long as your motor is strong enough. Yes, so this is a bit of a joke. You've already got plenty of them around the house, so go and start building robots whenever you like. As they are pre-made, they are very, very smooth, and you can buy them in all types of metals, different sizes, and whatever size works best for you. So you don't have to worry about cutting up any channel that you have. Yeah, you can buy them in the size that works best. So this would be an example of using a drawer slide.
Is that string?
Yes, this is string because you do need a way to pull it up, so the motor would be pulling the string. But in this case, I am the motor.
So a drawer slide can only be motorized using a string.
Yes. And again, it comes down with gravity. In theory, you could motorize it both ways, but it's easiest just to have it come down with gravity. Yeah, so there is a method for stringing it very similar to the cascading linear slides, but a little bit less work because the assemblies are already made, so you don't need to worry about greasing. Okay, so some general notes for any type of lift that you choose to put on your robot. Check your bearing sizes. If the sizes are different, you're going to run into some issues everywhere. So make sure that you have the right size to make sure everything is as stable as it possibly can be. Find string that doesn't stretch, because having the string stretch during your season is annoying. It won't always stretch uniformly, and you can't always predict when it will stretch, so you'll end up having to restring your robot almost every match. So it's really nice to either find string that doesn't stretch or pre-stretch it. Think about where your wiring will go, especially if you want to have a sensor or a mechanism, a motor on top of your lift. You need to make sure the wires aren't going to get caught in all of the cables going on your lift or in the mechanism of your lift. That's very important. Please do not chop up wires with a lift. It's very, very bad.
Any suggestions on how to keep the wires out of the lift?
Yes, using zip ties is wonderful. Zip tying them to parts of your lift that aren't going to move with a little bit of extra space around each of the joints to make sure that you're never bending your wires too much. Don't bend them more than 90 degrees. Please, it's bad for your wires. Watch the strain you put on your motors. All of these types of lifts are motorized, and you will need a motor in order to bring any kind of lift up. So make sure that you're not putting too much strain on your motors. Burning them out is a really bad idea. Make sure it's stable. You're going to be lifting things, which means it's going to raise your center of gravity. So you really need to make sure that your robot is stable and your lift is stable. It's not going to cause your robot to fall over. It's not going to collapse within itself. This is very important. Structural stability is a very, very good thing for robots, especially when you're bringing the center of gravity up. Beware of pieces loosening with use. So as your lift goes up and down and up and down, just like your drive base, it's going to require regular maintenance. A lot of pieces are going to loosen as you use them. So if you're using kept nuts, butterfly nuts, little ones that are not don't have the rubber gasket on them, then check and make sure they're not coming loose, because if they do come loose, it can cause your lift to have problems, collapse. It just doesn't end well. So please check and make sure everything is tightened. Give your lift as much attention and care as you give your drive system. If the lift uses two motors, wire them together. This is a very, very good trick because it ensures that any command from your robot's phone that one motor is getting, the other motor is getting as well. So theoretically, they'll be going up and down at the same speed, only dependent upon what kind of motor you're using, which is very good for making sure that your entire lift is not lopsided. Be prepared for lots of maintenance. As mentioned before, you need to give your lift lots of maintenance. This comes with building something that has this much movement in it. It raises your center of gravity, it has lots of little pieces. It's good to check it all the time and make sure that you have as regular of a maintenance schedule as you do for your drive system. And define criteria before you build it. Define criteria for your lift before you build it, please. Make sure that you know what kind of lift you want and why you're choosing that kind of lift. If you can use a very simple and easy to build lift, why go for the complicated one over it? It's best to follow the general principle of keep it simple. Yes?
A good source of non-stretch string on the island is
I should know this, and I do not remember.
sailing string.
Sailing string. That makes a lot of sense, actually.
Sailing rope and stuff, a lot of it is non-stretch, so if you find a good source of a sailing shop or a boating store.
Yes.
Also for knots, there are some really good non-slip sailing knots that you can also use.
Yes. There are a lot of very good sailing
This
knots
is especially
worldwide.
especially important if you're using cascading, because you cannot have the strings the different segments of string be at different lengths, so you have to make sure it doesn't stretch or it doesn't loosen the knot or shift the knot.
Yes, and be careful to keep the strings the same length when you're tying the knots, because it's very easy to cut them all the same length, but tying a knot where they're all the same length is not easy at all. So, yes, make sure you define the criteria you'd like for your lift. So what kind of lift is going to work best? Would you like it motorized but to go up and down? Is there any reason why you're picking a more complicated lift over a simpler lift? Because keeping it simple will reduce maintenance, it will reduce problems, hassle, and it will take you less time to build and program overall.
Space on the robot.
And make sure that you allocate space on the robot for your lift. Some of these lifts take up quite a lot more space than others, so you need to make sure that you can fit in that 18-inch sizing cube when you get to competition. So do not build a lift that is too big for your robot, and plan accordingly, which is why it's best to plan everything before you build it.
And keep in mind the 14-inch barrier thing.
This year's game.
There's a 14-inch barrier.
Yes.
Yes, so this year's game there's a 14-inch barrier that you need to make sure your robot can get under if you're going to be doing any of the challenges on the other side of that barrier. Yes, okay.
Alright, so now we're also open for questions, and we did make a bit of a chart just to help compare the different lifting mechanisms. Also, quick note, something I forgot to mention before about scissor lifts. For stabilizing scissor lifts, because you want to have two arms, we've found that it's a lot better to mount the two arms on an angle to each other instead of parallel. When they're parallel, they want to wobble in the same direction, versus if you mount them on an angle, they're trying to wobble in different directions, and they actually help stabilize each other.
A triangle is the most stable shape. When in doubt, build triangles.
If you are going to keep them parallel, you have to do lots of cross bracing to keep them from moving side to side.
Yes. Don't know if you were able to hear that on the live stream, but there was a point that if you keep them parallel, you want lots of cross braces to keep them not moving too much. We also have a couple other examples that we didn't talk about specifically for different lifts. This is pretty much another gear rack, except for instead of using a chain and a sprocket. So you can move this a bit closer. Can you see that? Using the chain has the benefit, chain and sprocket is often, doesn't slip as much as just a regular rack and pinion or gear rack.
These things have to be lubricated as well.
You don't need to be lubricated, I don't think.
No.
No, because they're stationary. The chain itself isn't moving.
They're usually pre-lubricated.
Yeah.
It's a very
Yeah.
nice and simple way of creating a small linear motion. I will state that it only works if you're doing one segment of linear slide motion. It doesn't work well if you're trying to create multiple segments,
Yeah.
but for single motion, that's one of the most effective.
Also, one example of an arm that you don't necessarily, if you're want an arm that reaches outside of your 18 inches, there are ways to fold them up and have them release, seeing as it only has to fit within 18 at the beginning of the match. So you can actually have elasticized arms. This one, for example, currently isn't elasticized, but you can have elastics here. When it's down, it's tucked in here within the 18 inches. Once the match starts, you can raise the arm, and the elastics will snap this out, and you have a larger arm to use. So it's just an example of how you can use elastics to fit arms inside of 18 inches before the match. Any other questions?
There's a question.
Oh, no, my head is like not functioning.
Any questions in the chat?
Is anyone even in?
Yes, we do have people watching.
Hey! Also, just a quick talk, mentioning with the different string configurations, you can use it for the rev slides as well as for drawer slides. We'll say with the rev slides, there you can do more with them yourself. It's easy, you can cut them to the length, whatever length you want. They take a little bit less room because the slides are all just pieces of channel as well that you can screw your pieces to and modify. I know when we used them a couple years ago, we drilled holes and tapped them in order to have more secure anchor points. With linear slides, because they're pre-made, they're a little harder to modify, and you do need to attach them to another piece of channel. So they, as mentioned with space allocation, door slides can take a bit more room up in the robot, depending on what you screw them onto. However, in the end, they tend to be a lot smoother, have a much smoother motion because they have ball bearings inside of them.
They also tend to, the burst lines tend to be very robust. Once you get one of those systems actually working, they don't tend to break very often, which is very nice.
Wait, just a person curiosity, can you print a linear slide? Like, not for heavy loads, but like something like light.
Probably
Yeah,
for
I
something
know.
small, yeah.
I mean, it would probably be easier just to go and buy one at the store, but it could.
Also, just because I have the rev stuff in front of me here, they've got wonderful bearings and pulleys that actually have covers with them to keep the string from falling off. One thing, notice I'm not using that for the string currently because the string is too big to fit for these pulleys. So if you do use the rev kit, do make sure you get the correct size string. If it's too big, it won't fit over it and will fall off, but it does have to be big enough and strong enough that it won't snap.
So does the string earlier, the sailing string fit on these?
Well, you can get all kinds of different sizes of sailing string.
Okay.
Yeah.
Advantages of having a store that suits an industry is they tend to sell a very large array of things in all different sizes because everyone has preferences.
Sailing string is good because it's designed not to stretch because you don't, just with sailing, you want them to robust.
Well, other than sailing string, what's like the second recommended thing that's not like sailing related?
If you can get like the thin, it's like thin steel cable wire, or metal, forms of metal wire that are actually designed to bend and go around pulleys. They're a little harder to source, but if you can actually find a good one, that's very nice.
Also, if you are using the continuous string configuration, it's not as important if it stretches or not because it's all one string, so if it stretches, you're just going to have to wind it up a bit more.
With whatever string you pick, beware of fray at the ends. It's really good to just burn and melt the ends so that way they don't fray and you don't have to retie them every few days, weeks, months.
Either that, or another good thing is get a little piece of tape and wrap it around the end to stop it from fraying, or find a way to burn the ends or whatever, find a way to stop it fraying.
Like
Yeah, I like to burn the ends as well.
Also, with scissor lifts, just another point is that the very first part is always the hardest for the motor to actually lift or pull up. And there are different ways you can raise this lift. You can use string and a motor to pull the bottom part up, but that can be difficult. You can also use string in this case, we use the first joint here and pull it directly up to make it easier for the motor.
It takes like a quarter of the power to pull it
Yeah.
directly from there as opposed to actually pulling it
Yeah, you're
from the
gonna
bottom.
try pushing this versus pulling that.
Or do it over in front of the webcam, it's better.
There, is that.
And if you're looking for a place to put math into your engineering notebook, lifts are great for it.
I'm weak, okay.
Yeah.
Yeah? Oh, okay, that's
Yeah.
good.
As you'll see, this is just one single one, and it already wobbles and moves around quite a bit. So you want a second one. Any other questions?
Has your team thought about a lift? From looking at all the choices in front of you today, do you have any questions?
Do you have any thoughts of what type of lift you would want your team to use?
if you use gears.
There are many different ways you can do it.
Yeah.
Even if you're pulling something, you will probably still need to have something that either moves it up or rotates up to be able to actually place it on top of the score.
Yeah.
If you want to like place it above, like on the foundation and then like on like the box to make like levels.
Yeah.
So for an example of a lift that's actually implemented on a robot, this is our competition robot from a few years ago.
So as you'll notice, the strings are very frayed on this one, but because we don't use it anymore, we haven't bothered fixing it. This is a continuous method. You notice it goes up. I'm just doing it by hand for now.
Oh, I love how
Yeah.
Wait, so is this continuous or is this?
This is continuous. Yeah. So if it was in cascading, it would have gone a lot faster.
because it wouldn't have been one stage at a time. But this is continuous because for this case, we only needed it really to bring it up once, and that was it.
It should also be noted that the cascading effect would take more power to lift up, so you may need to use multiple motors to power that.
Yeah.
Whereas you could probably use fewer motors to power it.
Yeah, so cascading does require more power from motors in order to lift it up.
Because you're continually hitting that increase in power that it takes to lift the first stage.
One thing noticed with this one is think about when coming back down, this one has almost no weight on it coming back down, and it does mean that if I just drop it, it tends to get stuck at some point,
And
like
we have
that.
to restring the whole thing.
And if something just forces it down, or if the motors were to keep releasing string, all the string comes off the pulleys. And it is no lifting mechanism is without maintenance, but I would say any lifting mechanism with string on it just skyrockets the maintenance.
That is one thing that I would recommend if you're using string is if you can 3D print a pulley which has a proper string case, keep the string on the pulley, and actually design and create your own pulleys.
And if you need another reason to get more women on your team, small fingers are great for stringing lifts.
That was me.
And me!
Wait a minute, like build this, like.
What, sorry?
This was their role.
Yeah. I was the one who was constantly restringing this one, and I was the only one that could tie the knots, so I was the one tying the knots when we tried cascading.
Why not use like tweezers or stuff? Will that help?
You get less control.
Yeah.
Yeah.
Do you want me to? You can try restringing this if you want.
Oh, I did last time.
Oh, you can string it now.
Yeah, it's already come off.
Is it on video?
Oh yeah.
Oh, that's
That was
fast.
the point. We
That's
put it up.
fast.
Here.
Yeah, where's
Oh my gosh.
Every
it's
single
stuck
match
now.
we were restringing this.
Yeah, it's already caught in some spots. It's come off the pulleys and gotten stuck.
That's
If you
fun.
could not sit in front of the camera, that'd be amazing.
Oh yeah, I did not.
So-
I thought that was there.
Yeah, no, it's
Here, I'll
okay.
get this last bit unstuck for you, and then you can.
I didn't bring my tweezers.
So Hanson, yeah, come around this side. The other side.
Adjust the camera. This is gotten caught between the pulley and the side end.
But like most string things, they now have like the caps, right?
Yeah, so this one, as you can see, we got our own ball bearings, and we kind of made our own little cages for it to keep it from sliding out.
Yeah, we tried 3D printing the bearings, but we found that they just had too much friction and didn't work very well.
The now Rev has little bearings with cases on them. However, that's what I was mentioning. Make sure you have string that fits inside of it.
Do you want to try bringing over the vacuum pinion again? Because it seems like where the camera is now, the light might work better.
The vacuum pinion is back, I believe.
Yes. Sorry. We just weren't able to show it very well before. But down here seems to be doing a better job of
Okay.
lighting.
Good. Good? Okay. So the motor will be attached, have a gear to spin this one. I just got it moving back and forth here. You can see it there. It's just got a gear rack made out of plastic with little hooks on this side to keep it on. That's why these sections are in not very long, so if you want to go further, you have to get multiple sections, and then you have run into issues with the little clamps getting caught between them, which is why you can really only use this method in small sections. And then each section needs its own motor.
But for the small sections, it works really, really well.
Yes, and you got lots of control because you can power it up and down easily.
And stop it at certain spots.
Yeah, I would say that the rack pinion and the sprocketing chain linear slide are almost the same in that respect, how they're both really good for short linear motion.
Yeah. Having fun there? Having fun?
I actually am.
Oh good, you can do the other side
I
afterwards.
think it
Yeah, I
started
love-
taking like 30 minutes at the beginning and then got it down to 5 minutes close to the end of the season.
Yeah. Yeah, you get better at it with time.
If you practice enough.
But yeah.
When you
And
practice
also-
enough.
Maintenance for scissor lifts. For this one, for example, after every match, we want to double check that these are all loose enough that can move freely, but not too loose that it's causing stability issues. unless there's.
I think that's all the questions that we have.
Okay.
Oh, did we want to mention the next?
Oh, yes. Good catch, Ellen.
All right. Quick reminder for next week. On November 1st, again at 4:30, you're going to have a workshop on the engineering process and notebooks. The actual presentation part isn't going to be that long, so we encourage you to bring your robots, and we can give you feedback, and you can get ideas or ask questions with your robot right there.
Should you say bring your robot or bring your notebook?
Bring your robot. You can bring your notebook too.
You can bring your notebook and we'll give you some tips, advice on it. But bring your robot, we'll be discussing the engineering design process and a bit about engineering notebooks.
And should have at least half an hour to actually help troubleshoot and
Yeah.
whatever teams need.
Exactly. Experienced alumni here.
Hopefully, we'll see some people there.